Hello, green software lovers. Today we have a fantastic opportunity to delve into the realm of cloud efficiency and the creation of sustainable applications. In today's global context, this subject holds significant importance, and we're excited to raise awareness by sharing valuable tips and insights from esteemed experts. And it's absolutely our privilege to welcome Paola E, a distinguished figure in the Green Software Foundation and an engineering manager at Microsoft. Paola will walk you through current techniques employed to make applications environmentally friendly, including actions you can take within the application to optimize energy consumption. Thank you, Paola, for joining us. By the way, remember that you can start asking questions using our YouTube chat right from the beginning, and at the end of the session, Paola will address them. All right. Now I give a word to you, Paola, and very excited to know more
Thank
about
you.
the subject.
Thank you. So first, let me share my screen because we have a lot of things to see today. And good afternoon or morning, wherever you are. My name is Paola. I am an engineering manager at Microsoft, and I am a speaker and an enthusiast of the Green Software Foundation. Today, we will talk about how green software is becoming a new topic and discipline that involves the entire IT department. And we want these uh, applications to be more efficient and greener. And we want to understand how owners and developers can be involved in keeping this infrastructure as close to carbon neutral as possible. So first question that I always try and ask at this point is how familiar is the audience to the concept of cloud efficiency and green software? And you are welcome to write in the chat or ask any question. But the point is, we know what the problem is. The problem is climate change, and we, until now, the IT and developers have never been involved into dealing with climate change in our work life. We know we do our part at home, but we've never been asked to do anything uh, on the work side. And so let's start with what is cloud efficiency. I already see some questions in in the chat. I will get back to you soon. So first of all, what is cloud efficiency? It means making the best use of cloud resources in with the lowest consumption and minimal waste. When we waste resources, meaning hardware, even in the cloud, because we're still talking about hardware in our data centers, then we are wasting energy. And when we waste energy, we waste carbon emissions that are produced to have that energy up and running for our hardware that is maybe useless. So that's the main point of cloud efficiency. We want to really being able to use what we need and not waste anything. This is more important, mostly important also because in the wider picture of carbon math, first of all, well, we know we have a problem. Greenhouse gas emissions are a problem. Also, when we talk about carbon, this is an approximation. Carbon means CO2 equivalent. We have done the math. So when we cut it short and talk about carbon efficiency, we know that the greenhouse gases are not just made up of carbon dioxide, but gases, they do not all have the same impact on the environment. So there is normalization to do. We use this convention, but behind the convention, there is the math that will do the normalization for you. So the problem we have is that the increasing temperature does not depend on the rate at which we emit carbon, but on the total amount that is present in the atmosphere. So to stop the increase in temperature, we have to avoid adding to that already present. Or, as we used to say in companies and in the green software environment, we want to reach the goal of zero emissions. But of course, we need to still live on the planet. So that means that for every gram of carbon that is emitted, we have to take the same amount. it's not, I mean, this is an ambitious goal, it's not impossible, but we have to do something. And I'm sure after this presentation, you will know what to do. So a brief anticipation on what this Green Software Foundation has been working on. The state of green software was a survey that was recently published and used qualitative and quantitative questions. And one of these questions was really around what software-related carbon emissions account for. So we know that they account today as for 4 to 5% of the global emissions. So this is the equivalent to the emissions of all aviation, shipping, and rail combined. So we don't have precise estimates of software-related carbon emissions. They can be different according to the methodology used, but typically what we're talking about is digital devices, data centers, and networks. These are the three main culprits. Software development itself can be energy intensive. Think about training large language models. This is such a hype today with the AI model and everything. And there's a Harvard Business Review that is estimating that by 2040, software is expected to account to 14% of the world carbon footprint. So we now know what the problem is. We know that in the software world, we are part of the problem. What can we do about it? This is the interesting part. So one of the things we've done that made quite a big impact was co-founding the Green Software Foundation. When I say we, I'm talking about Microsoft together with Accenture, GitHub, ThoughtWorks, the Linux Foundation. This is a non-profit organization. It was born in June 2021. With the mission of building an ecosystem of standards, tools, and best practices to build green software. And again, everyone is encouraged to join as a company or as an individual. The scope is really narrow. We don't cover things like using the grids or using software for green purposes, but rather specifically just the build of green software. We want to build applications that are green, that don't waste energy and resources and carbon emissions. We have members today in over 190 countries and a combined workforce of over 1.5 million people working on the Green Software Foundation. This was born out of a very small team and is now becoming a foundation that can really make an impact. And the target of the Green Software Foundation is mostly on Scope 3 emissions, so indirect emissions. And the focus is really reduction. We don't care about anything else. 1 gram of carbon not emitted in the atmosphere is not the same as 1 gram of carbon that has been offset, for example. So the most preferable goal to us is to never have emitted the carbon in the first place. And of course, reduction is more challenging. We know that. Let's see how. And dive into the principles that make an application green. These are 6 main principles. I'll go through each of them and very quickly, but you are encouraged to go and search on the website. There's material, information, articles. So first of all, carbon efficiency. This is the first thing. We want, because everything emits carbon into the atmosphere, for software to be green, it needs to extract the maximum value for every gram of carbon that's emitted into the atmosphere. The goal is to build carbon efficient applications. The maximum degree of use of servers and services must always be the primary objective. And generally, this equals to, at least in Azure, in the cloud world, to cost optimization. So it's also nice for your pockets. The most efficient approach is also the cheapest. So what's wrong about it? Second principle, energy efficiency. Applications must use electricity efficiently. Again, this is something new, maybe not new for developers who were used to work, for example, on mobile applications, because they had an issue of consumption of battery. And so they had to know how much energy the application was going to consume. Now we have to do a similar exercise for every application, regardless that it's using batteries or not. We wanted to use electricity in an efficient way. Third one, carbon awareness. And this is something we will develop over the presentation because it's a very important concept. But the main idea is we want to be able to do more with the application when the energy comes from low carbon sources. And we want to be able to, or trigger, possibly in an automatic way, to do less when more energy comes from high carbon sources. So we'll see that about during the presentation. But the point is we need to know when the energy consumed is greener or not. And there's a catch for that. Fourth principle, hardware efficiency. This is the so-called embodied carbon. So it's the amount of pollution that was emitted during the creation of the device and that will be emitted during the disposal of the device. So an efficient application should run on older hardware because it will have an impact on the emissions due to the non-disposal of all devices and will somehow spread the emissions that were created by producing the device across its lifespan. So very important. For end user devices, extending the lifespan, but for example, for cloud computing, it's increasing the utilization of the device. And that we know. Measuring, of course, we need to measure everything we do. And this seems odd, a very straightforward principle, but it's really probably the trickiest one because we need to agree on what to measure and how to measure a green application. So that's the main point of it. And last but not least, the goal, the commitment is, as I mentioned earlier, in reducing emissions. We are not caring about abatement or offsets or compensation or neutralization. We really want to not emit carbon in the first place. And that's our main goal. So what makes software green? Building green software requires a lot of thought into it. There are only 3 actions that reduce the carbon emissions of software. One is using less energy, either consuming lower carbon sources of energy or consuming electricity in a way that helps accelerate the energy transition towards a low carbon future, which is what we want. 2, using less physical resources or simply support older devices to lower the embodied carbon. And 3, using energy more intelligently. And we'll see more later with the carbon awareness concept. So one of the questions is maybe, what is Microsoft doing on this? Because we are part of the Green Software Foundation, and because this was a small team that came out of Microsoft somehow, we also pushed back into our own company to start doing stuff. As a cloud provider, for example, there is a shared responsibility model for sustainability. It means that there are 2 layers of that. So one is, again, as a cloud provider, we have things like Project Natik. Those are underwater data center and that type of stuff. We're providing system and tools and services to customers as a cloud provider for that managed layer. And another example is, for example, the Sweden data center, which is right now the greenest data center we have globally. It's super green because it's fueled 100% by renewable energy. So if you have to choose a region and you are free to choose wherever you want to put your stuff on Azure, go Sweden. The second layer is Microsoft as a software provider. And of course, this is where we have other examples of how we can make things green. For example, I don't know if you are like me and you've got like 100 different tabs open in the browser and you keep them there because you're too lazy to bookmark. Bookmark is probably something from the 90s. And so they're open, but if you see on Edge right now, they turn a little bit light gray. And then if you hover over it, it will say that the tab is now sleeping and it's saving an amount of energy. Because guess what? Just keeping a page open in the browser, keeping a tab open in the browser is consuming energy. And maybe you will not open that tab for another week. So close it. Or use a browser that is saving. energy and of course emissions out of it. Another example is the Windows updates. For example, Windows 11, the Windows 11 upgrade now takes in your local carbon intensity value for the energy grid of your location, and then it will delay either installing and downloading updates to Windows until the carbon intensity is lower, and that means that there's more renewable energy in the grid at the time. So we're trying to work, and we have other examples on Xbox, on of course, on the AI implementations. Everything is, we're trying to go green on that. Another thing we did was in 2022, I think it was November last year, we released the guidance for our Azure customers within the well-architected framework. Because one thing I always say is use a green data center, but using a green data center doesn't mean that you can waste these resources because they are green. So there is, again, a shared responsibility in how you use the resources that I am giving you in a green state. And so this is a set of guiding suggestions and tenets that can be used to improve the quality of a workload. And there are several pillars on the well-architected framework. For each of them, there is a green software, a sustainability action to it. Tools, what tools we have as Microsoft? We have the emission impact dashboard. So we provide a dashboard that will tell you how many carbon emissions your Azure or M365 clouds are producing. And we also have the sustainability manager, but this is more like a software tool for sustainability. So it's not a green software thing at the moment. So, but okay, now we've set the stage on what is cloud efficiency, what is green software, but what is it that I have to do, really? Okay, and so let's dive into a bit of green software best practices. If you study all the possible ways of reducing carbon emissions within an app, they all converge into something that we call an eco mode, a version of your application that has the minimum set of features and graphics that will guarantee the basic services while emitting the lowest possible emissions. The eco mode will have, for example, bandwidth reduced to a minimum, DB queries only the necessary, and laser cut choices, low resolution graphics, especially if it's mobile bound. By the way, features, are your users using 100% of them? There is an infamous report by Standish Group that is stating that a staggering 45% of features on average are never used in any software. Do we really need them all? And I know that as developers, we never take away features because of how the software works. I know it's not considered feasible or a best practice, but if we took them off, or let's say that if we build this eco mode, then suddenly we could also realize what are the really important features of our application to our customers, to our users, and then increase the performance of the really important and used features and maybe get rid of the others. Another concept in cloud computing, right sizing is the process of optimizing the size of your cloud resources based on your workload requirements. This is a strategy that is used to match the amount of resources you're using to the needs of your workload, and it helps to improve efficiency and reduce costs. Guess what? It also reduces emissions. So use only what you need. This is first. And then the very first carbon saving technique is very simple and intuitive. Schedule your applications to run only during your workday and switch off every possible service during off hours, if it's possible, of course. This will save cost and energy, but we realize that this is not always possible. I have in the title put static pattern, because sometimes applications are not static, they are dynamics. And so it will require a bit more intelligence to this action. But this is like the basis of it is each action. Use only what you need and schedule everything so that you are keeping resources on just when you need them and when you're using them. Another thing is using the right resources, because when you build application in the cloud, you have a lot of flexibility, more flexibility than ever before, and that comes with critical decision making. So services that run only when needed or that scale automatically as demand increases make for good choices long term because they are more sustainable. So it's true that if I choose a microservice application, it's nice because it's in the path of cloud native, but it's also in the path of green software, because I can scale exactly only the service that I need, the microservice that I need, and nothing else. And so, yes, there may be a higher investment up front, but the return can be significant on energy, hardware, emissions, and money. It will save you money. Another great example is Go serverless. Developing serverless applications will give you the best solution to have highly scalable, high performing workloads. And we know that the serverless resources have been previously assessed and optimized by the cloud provider. So you can be sure that you are using the resources exactly when you need them and how you need them. Storage. This is, I mean, I always deal with the customers' deployments and implementations, and the common thing that I always see is storage. You have to have practices for managing the long-term retention of data, because we tend to accumulate storage, snapshots and backups and disks and everything that holds our data. We are storage huggers, as a friend would say. But in reality, if you have a file that has not been accessed in 2 years, do you really need it? I mean, maybe for backup, you can safely create a policy that can delete that object. And there are tools in Azure that can help you with that, but there are tools in most all of the cloud providers that will help you manage storage. But storage is really an important part of our waste of resources. Another thing that I see often is ghost resources. Um, I mean, ghost resources are things that are unused or idle, or somehow they have been left behind by deletion or optimization. They're simply there. In some cases, they are burning money. In other cases, they're not consuming money directly. And I'm thinking, for example, a network interface, or well, an IP, a public IP address is also has a cost associated. But yeah, root table, a resource group is not costing you money, but it's still costing you resources. If it's empty, if it's unused, just go and delete it. And this will also make your cloud data center easier to manage, because suddenly you don't have a lot of stuff that is there for no reason, and you only have to deal with the things that are useful. So, I mean, beyond everything that we have discussed, what we really need you to do is to basically put in place a FinOps and GreenOps, I would say, process. And it's a continuous process, unfortunately. So it's not something you can do once and then forget about it. You have to do it on a recurring basis, possibly weekly, even daily in some cases. So you have to review your emissions, then state, okay, these are my requirements. I want to set my limits and goals and see where I can get to. I want to right size, automate, clean up, do everything that I can to optimize, modernize my application, and then measure again my emissions and see again how can I optimize. Because obviously this cycle could be made of just one run if we're talking about very static data centers, maybe on premise, but in the cloud, once you've done all the round through the FinOps, GreenOps process, you have changed. The data center and the virtual data center has changed already, and so you are back from where you started, where you don't know, you don't have full control of everything that is going on around you, and you need to start again from scratch. Again, this is good for FinOps, so financial, but also green. Let's dive a bit deeper into the concept that I mentioned earlier of doing things when the carbon intensity is low, doing more things when the carbon intensity is low, and less when it's high. So if your work allows you to be flexible with when or where you run your workloads, then demand shifting is a good technique. It means consuming electricity when the carbon intensity is lower and pausing production when it is higher. For example, you could train a machine learning model at a different time or shift it to a different region with much lower carbon intensity. And it can be, again, spatial, meaning that you move your workloads physically into another location. This might seem easy or not, depending on latency, on data sovereignty. I mean, there's a lot of constraints to it. But if you can't shift your workload spatially or to another region, then you still have an option to shift it to another time, perhaps later in the day or during the night when maybe it's windier and then the carbon intensity is lower. And there are some great examples out there of companies that have recognized the importance of carbon awareness. The example that I was doing earlier, for example, was on Windows 11, running the updates when carbon intensity is lower. And then there's another technique that is slightly different, that is demand shaping. It's similar to demand shifting. However, instead of moving demand to a different region or time, we just shape our computation to match the existing supply. And so we want to do more when the carbon intensity is low, and we want to do less when the carbon intensity is high. This can happen in an automated way, or you can leave the choice to your users. Eco mode, for example, the thing that we started talking about in the beginning, is an example of demand shaping. And in eco mode is something that we find in everyday appliances. We have it in our electric car, for example. I have a plug, that a software that tells me how long it would take to recharge the battery of my car, depending on the time of day and on the hour when I want the charge to be done. And because of this trade-off with performance, eco mode is always presented to the user as a choice. I can choose, because if I have to leave my car charging all night, I don't care if it's charged at 2 a.m. in the morning. It can take less time, but wait and go slower so that the request for electricity will be lower across time. That is just an example. Another example is any video conferencing software will adjust the streaming quality automatically, because rather than always streaming at the highest quality possible, it will reduce the video quality to prioritize audio, for example, when the bandwidth is low. So this is a mechanism that is already in the application. We just have to apply it for the green cause rather than the bandwidth cause. And again, another example, another take from our State of Green Software survey, that, by the way, you can find it at the link. Carbon-aware software will likely be a growing field of practice. According to the survey, 8% of software practitioners told us that they already create carbon-aware software, and another 46% told us they wanted to implement carbon-aware software features. And so this is something that is taking over the green software movement, because the idea is very simple and it will help you optimize your applications, but also optimize, again, cost and carbon, the whole cloud efficiency picture. And I wanted to show you a live demo. Let me see. So there are a couple of sites, probably more than a couple, but a few websites that offer APIs. And these APIs will give us real-time intensity of the power grids according to the region where they are. So this is a live example, and it's pointing to Europe. I am based in Italy. Let's see if I can zoom in, and I'm not doing very good. Northern Italy. So for each region, it will tell you what's the carbon intensity, meaning carbon grams emitted, and what is the mix of power that is, what is the mix that is fueling the electricity. So what it's saying is basically 43% of electricity available in northern Italy comes from gas. Not good. So with this information, I could work on my application to match that in the morning, because we don't have a lot of renewable energy going on. We have to burn gas, and so I want my applications to be able to do less. And this was a great example what we saw, and again, um, it would be great if someone did something automatic about that, would it? So this was one of the first open source projects by the Green Software Foundation. It's the Carbon Aware SDK. You can build software that chooses to run or to run more features when the wind is blowing, enable systems to follow the sun, or moving around the world to where energy is greenest. This is an SDK. It is an open source project, so you can find it on GitHub. You have the repo link in the slide. And so basically, this is a web API and CLI with identical functionalities. The API can be deployed as a container for easy management, always, and can be deployed alongside an application within a cluster or separately. It will basically hook up into these APIs for carbon intensity, and in near real time, I would say with an hour interval, it will check what's the carbon intensity and report it back to your application. It is then to you to decide what should your application do once it has the information about the carbon intensity. And we have an example for that as well, because Microsoft and UBS decided to collaborate with WhatTime through the Green Software Foundation. And so this is a case study for the first enterprise-grade carbon-aware application. And the tools and architectures are now open source, so you can find everything on GitHub. And so just to give you a few examples on this MVP, this was created using the UBS Core Risk platform, on which Azure batch workloads are shifted to times with lower marginal carbon intensity within the 24-hour window. The selection criteria for the application were computational intensity. So we wanted an application that is consuming a lot of resources, a lot of cores, and so a lot of energy. Short durations. So these were the batch workloads. They used to run 30 minutes or less. High volumes and deferrable start times. Is it something that I can run at night? Does it change my outcome to the user? And you are free to go and read more in the link where you find the full document explaining it. Okay, back to the measuring point, which was one of the trickiest thing that we saw in the beginning. How to measure your application efficiency or footprint. So one of the goals of the Green Software Foundation has always been to create standards, and the most important one is what we call the SCI score, which we'll see in a while. It's a methodology for calculating the rate of carbon emissions of a software system, and to help you developers to make an informed choice about which tools, which architectures, and which services they want to use in the future. But let me tell you a bit of an example. Imagine that you are the leader of an organization, and you are charged with reducing the emissions of your software. You take steps and you measure the total emissions. In Q1, you have 34 tons of carbon. you made some investments into projects that eliminate emissions. So you do the right sizing, you do the cleaning up, you optimize, you even modernize your application. And by Q2, the emissions are now 52 tons. They have increased. How comes? A total by itself does not tell the whole story. We need other metrics to help describe what's going on. For example, if we looked at the carbon intensity as well as the carbon total, we might see a different perspective on what happened. In Q1, my software had a carbon emission of 3.3 grams per user. But in Q2, after my optimization, it's been reduced to 2.9 gram per user. Now I can see that my optimization was a good one. The total informed you that your organization carbon emissions had increased overall, and that might inform one set of decisions. Maybe I need to have less users of my application. But the intensity informed you that the choices to eliminate emissions are working. It would be best to continue in that direction to gain even further reduction. So here's your balance. You have a number of users that are increasing and emissions that are decreasing. You can decide if you still want to serve the totality of users or maybe lower the number of users, but the optimization process was the right one because you can see results. And so we put everything together in this software carbon index, another product of the Green Software Foundation. It's quite simple, actually, because the formula is carbon, C, multiplied by R, the scaling factor. Carbon is a mix of everything because it's the energy, E is the energy consumed by a software system, I is the location-based marginal carbon emissions, M is the embodied emission of a software system, where you calculate the whole ecosystem of the application. Basically, the scaling factor, which can be, I don't know, API calls, it can be users, it can be number of HTTP requests, whatever your application is known for scaling. That's your number that you will use to understand what is the software carbon index for the application. And of course, just one note, I'm aware that we don't have all the data. And for that, for the whole ecosystem of the application, you might have the data for the infrastructure coming from the on-prem data center, coming from the cloud data center. You don't have everything along the way up to the end user device that is consuming that application. So there are ways to indirectly link to carbon impacts, and they don't represent an absolute value, of course, but they can help you identify changes. So what we're really interested is the delta. We want to see the behavior of the application going down. So the metrics you identify will lead you to optimization. You need to pick the right measurement criteria. And of course, this depends on the application. But they are useful to identify metrics to keep control on how things are doing within the application. And you have some examples here to reflect. Now for the new part. What other things is the Green Software Foundation working on? A lot of things. First one, the Impact Engine framework. This is a framework that will help model, measure, simulate, and monitor the environmental impacts of software. And it's integrated with the SCI Open Data, so with the software carbon index that we mentioned earlier. So the impact framework, or IF project, will be integrated with a lot of multiple data sets that can be used to provide carbon emission values. And the data sets can be private or public, but the whole point is we need to put together all the reference emissions and build a framework that will help to measure and monitor the application. And everything is still open source. You can go find the the GitHub repo for it. SCER, or I don't know, similar to the Energy Star or fuel economic ratings. We want to rate the software carbon efficiency. We want to give it a flag that says, for example, I don't know, I love the A2F carbon rating of appliances because they are so immediate. You can see they even have a color coding, and this is it. The project wants to develop a standard for a benchmark platform and test metrics to evaluate the carbon efficiency of software. So it will provide comparative scores for software with the same functionality, and then possibly we can create a standard for, again, a rating of applications. And last but not least, the Green Software Maturity Metrics. This is a way of the Green Software Foundation to address four problems. Where do I start? Where am I now? What am I heading towards? And how do I know I am making progress? It's basically helping you build a map of your organization applications and understand where you are at and what is the direction to take towards green software. Again, open source, where we're talking about draft projects, so you can go and read the documentation, you can contribute if you want. But before I wrap this session up, I just wanted to share another few things, findings from our state of green software. First, green software tools. So we have, I mean, it seems like a good number, but so we define green software tools that have an explicit environmental dimension in their name, topic, or description on GitHub. And we found that there are 2,000 specialized green software tools available. Now, 2,000 seems like a good number, but bear in mind that in 2022 alone, there were 86 million new GitHub repositories. So what this tells us is there is a lot of work to do, and the contributions we make today will have a big impact in the upcoming years on green software. Almost there, net zero future. So almost half of Fortune 500 companies have commitments to reduce emissions by 2030, and we're almost there. It's a few years up to that. So what we found in our survey is that almost half of the respondents said that their companies have public and comprehensive climate goals. Another 22% have public goals. So there is a lot of focus on net zero future, and while a lot of focus has been on data centers, in reality it's the end user devices, including laptops, tablets, phones, and printers that contribute to the most emissions. There's a study from McKinsey that says personal devices contribute 1.5 to 2 times more than data centers to the carbon emissions. And so tracking and reducing emissions connected to these devices will be crucial for achieving net zero goals. Last but not least, because I am a gamer and I love playing with my my video games, the gaming industry is a segment where green software principles are playing an increasingly significant role. And there are studies saying that the game industry is going to be worth 320 billion by 2026. It's like, what, 2.5 years from now, maybe less. And so the gaming industry can have a very high impact on reducing global emissions. So just as an example, Microsoft released the Carbon Aware Xbox, and during the 2023 Game Developers Conference, we announced that the Xbox would be the first console platform to release dedicated energy consumption and carbon emissions measurement tools, so that game creators can understand and reduce the carbon footprint and energy consumption that are produced by the games that they are developing. And we're talking about a huge impact here. So with this, I am finished with my presentation. I will leave you some links to have fun with, but now I'll try and maybe answer some of your questions. Like, let's go from the beginning. Uh, Software best practices implemented by Microsoft, I think we have seen those in the slides. What are your favorite green software tools? I do love the carbon intensity APIs, the electricity map. That is lovely because it tells me in every location how am I doing with energy, and it's good not just for the computer stuff, but also for example, for charging my car, my electric car, or doing stuff at home that I know that if I do it now, that the electricity intensity is maybe too high. What green software influencers do you follow? I am a fan of Azim Hussein, who is the chair of the Green Software Foundation, and he's probably my personal influencer on green software topics. Green Software blogs, I encourage you to go to the Green Software Foundation. There's a blog, but I mean, at this point, we want to create awareness. So I would recommend any blog, any green software blog, where you find useful information or ideas that can create awareness and that can change the way we develop software. What books or articles would you recommend? A couple of colleagues from the Green Software Foundation recently released a book from O'Reilly, which is called Building Green Software. I think that would be my first read. And it's basically also the foundation for the framework that we saw earlier from one of the projects of the Green Software Foundation. So the Green Software Maturity Matrix comes out of the book. So that would be my first book to read. What events would you recommend? Any events talking about green software at this point are good because they share the knowledge and are good to share ideas and to do something. And what I encourage you to do as developers is, if you have a new idea, make it public and share it with a wider community so that your single idea will become maybe 1,000 ideas across the green software movement. Does Microsoft plan on publishing the product carbon footprint of individual Azure instances? Yes, we have plans for that. It will come at some point together with the cost API, I believe. Yeah, right now we only do it at subscription level. In terms of carbon footprint, we want to do it at individual resource, so that together with the usage, you will have time of usage, cost, and carbon emissions produced by that resource. Last question. Last year, Carbon Hack was celebrated by Green Software Foundation. Is there any hackathon planned for this year? Do we know if the winners keeps doing their project and use them someplace? There is a hackathon planned, not for 2023. I believe it will be for next year. Do we know if the winners keep doing what they do? I don't know. I don't know, because some of the projects were pilots, they were MVPs. So at this point, I am not aware of any of those projects that was gone into production. So far, the only public one we have is the UBS white paper, so that is in production. But again, I encourage you to make it public, because it seems like customers are a bit shy on making public their successes on green software. So that is my call to action. Make it public. If you're doing anything on green software, make it public as much as you can, so that others can leverage your idea and your experience and improve it and make it better. Abel, do you have a timeline for that? No, I don't. I'm sorry. Unfortunately, I don't have a timeline. We're working on this, though. I don't know if there's any other question. Yeah. Oh, yeah, I agree. We really need accurate emission factors for embodied carbon. Well, if by embodied carbon you mean the hardware of the data center, I am assuming that the embodied carbon is somehow dealt with by the fact that if I'm telling you that a data center has zero emission, I somehow took care of it. But on the other hand, you still have the embodied carbon of everything that is in between the data center of the cloud provider and the user. And there is a lot of stuff. Think of the network, the edge, IoT devices. Before getting to the user device, there's a lot of stuff going on. And so it's not easy to have this accurate emission variables calculated. This is why we use proxies, but I mean, using proxies is still a valid choice and a valid methodology because it will allow you to still work on the delta, on the difference compared to what you were doing before. What first steps would you recommend individual developers to get started with this path in their organization? Well, the first step is, and I've worked on this with several customers now, is choose your battle. Pick your application, pick just one, because it would be impossible to start doing the exercise on all your application. I'm thinking of customers and companies having maybe 1,000 applications. It's just too much work. So start with one, pick the right one, the right application where you know you have freedom to test. You can optimize. Maybe you're planning a modernization already. That would be perfect because then you measure before the modernization and after. And then it means that you can measure the delta and then proceed from that with the software carbon index, the SCI score. So that would be my suggestion. Start with one application, and then if you find it successful, spread the same methodology to all the other applications in your company. There is no zero emission data center. How can it be? Ask the Swedish. I don't know. This is what they tell me, that all the energy is actually what I know is not only Sweden is the greenest data center we have, in some cases it's producing more energy that it consumes. And so what we're doing is we're selling back the energy to the energy provider or lending it back. I don't know how it works because I know that we have a battery problem on a global level, right? So when we have renewable energy, we don't know how to store it. It would be great if we could store it in a cheap and efficient way. If Tesla would produce these great super batteries that we can store all our renewable energy. Because right now, when we have too much solar power, we just throw it away. There is very little we can do. Same goes for wind and geothermic energy. So the renewable energies, the energy in general cannot be stored. So that means that even if you have more when the sun is shining, at night you still have to burn gas to produce energy. But I am not an energy expert, guys. I'm a computer gal. Sorry.
Okay, it seems like we don't have any other questions. All right. Thank you, Paola, for the enlightening and motivating session. We're aware of your continuous efforts to stay updated on new practices and initiatives. So I have a strong sense that next year we'll be organizing another event to share the latest findings in 2024. So thank you
I would
again,
love
and
to.
let's touch.
Thank you for having me. Thank you for all your questions. I'm happy to answer questions online. You can find me on LinkedIn, on Twitter or X, whatever it's called now. But yeah, feel free to reach out to me. I'm happy to talk about green software anytime.
Thank you, Paola.
Thank you. Have a great day.